This is Antic, the Atari 8-bit podcast.
And they basically went around the table and said, this project, this computer project, has software in it, therefore it belongs in my division. No, this project has hardware in it, therefore it belongs in my division.
But he has a Kermit the Frog tack. And I said, oh, nice tack. And he says, yeah, this is a close personal friend of mine. I look up and it was Jim Henson.
The research lab, or a chunk of the research lab, had a completely fictional manager named Arthur T. Fischel.
This is Antic, the Atari 8-bit podcast. I'm Kevin Savitz. Bob Alkire and Steve Saunders worked in Atari's corporate research lab under Alan Kay, where they worked on the Rainbow GPU. Rainbow was a next-generation graphics chip after Antic, which was never released. This interview took place on June 10, 2016. The first voice you'll hear is that of Bob Alkire.
I knew I was going to be an engineer from early childhood. I grew up in Los Angeles. I did ham radio, science fairs. I designed my own radios, played with explosives, scrapped TVs. I built my own circuit boards, usually using nail polish as the resist that I swiped from my mother. And out of high school, I got a job with Hughes Aircraft as a technician. And it was like a playground for me. They had a lot of technology there. They had computers that I got to play with the first time. And I was always volunteering to design stuff, even though I was a technician. And most of the guys around there allowed me to do it. And one time I saw an 8080 processor in an engineer's office in a nice plastic case, and I asked him, hey, I can build a computer around that. He says, if you can build a computer, I'll give you this chip. And this was at a time when the 8080 was experimental, and they're only releasing it to a few well-known customers, and Hughes was one of those. So I drew up the schematic and with help built a wire wrap rack mount system around this chip. It was actually really pretty. It was had a polished front panel, lots of LEDs, lots of switches. It was my first computer design, one of the very first 8080 systems at Hughes, and we used them in the test fixtures for testing satellites. This attracted the attention of another engineer, Steve Alkire, who later went to found a company called Microdasis. And there I designed a 6809 S100 board, again with an experimental processor from Motorola. I designed a floppy disk controller, and I wrote assemblers in Fortran for the 6800, 6809, 8080, and Z80. And I used Fortran because that was the only thing that would compile on our 8080 systems. I also gave away the source code because I thought that was the right thing to do. The next big job got some publicity. It was called the Miniframe. It was a 68,000 base server with a 6809 service processor. I did the schematics on a drafting table, and they were laid out with Bishop graphic pads and black tape on clear plastic film. I was happy to have it completed and get it working, but the design bothered me. At a Las Vegas computer show where we were demonstrating the Miniframe, a competitor had another 68,000 computer, and it was a lot simpler than mine. And the reason was they actually had a balance between the hardware and software. They were doing a lot more in software than I was. And I thought that was really cool. And it became a recurring theme during my career. Because after Microdasis, just to back up, we had done a lot of advertising, and it got picked up, and I got a call from Dale Yoakum, who saw the Miniframe in a trade journal, and wanted to know if I could do that for Atari. And what I wanted to do was a 68,000 base computer with bitmap graphics that could be a desktop. So I joined up Atari's Sunnyvale Research Lab in 1982. It was headed by Alan Kay and Chris Jeffers. The lab was primarily researchers, and they came from Xerox PARC and MIT, and there were engineers like myself. And I was hired in to design a computer. There was a couple of chips that were going on. There was the Amy chip, which is the sound chip, and there was a team behind that of 4 or 5 fellows, and then there was a graphics chip effort, which was, at that time, just Steve. And he had come up with an architecture. Now, at this time, every major semiconductor manufacturer had their own processor. And there was somebody at Atari that would champion each and every one. And this was just chaotic. Mm-hmm. Given that, and the fact that that you had a computer that needed to be designed, but it was going to wait on 2 major chips, the sound chip and the graphics chip, it seemed more fitting to work on the graphics chip. So that's when I asked my management that it would be a better idea to join Steve and help him out with the Rainbow Graphics chipset.
Cool. All right, let's pause here if we can. We'll put a pin in that. And Steve, I'd like to hear your voice. I'd like to hear your prehistory and how you ended up at Atari. Sounds like you were already there doing stuff when Bob got there.
I think I was a little earlier. Yeah, I'm not quite sure. I was the same kind of dangerous young tinkerer, and went to MIT thinking I was going to study physics. There was a freshman elective open. I thought, well, physicists will need to calculate things, so let me take this computer course. And got completely seduced. There was a PDP-1 computer that had the original Space War on it, and I spent a lot of time doing that. Switched to computers, finished the physics core curriculum, but my degree was electrical engineering, and then I went to Carnegie Mellon in computer science for a PhD. Wrote a thesis on a compiler that made up microcode for its instruction set as it went along, and encountered Alan Kay there, who was looking for summer interns. So I leaped at that and spent a couple summers at Xerox PARC doing musical sound synthesis. The FM algorithm had just been invented, and the folks at Stanford were running a Fortran-based FM sound generator overnight and writing samples as they were generated onto an audio tape, and they would come in the morning and play the sounds they had generated overnight. That just seemed like not the way a musician wants to work. PARC had just built the Alto computer, which had about the same main memory bandwidth as the PDP-10s, and it was microcodable. Mm-hmm. So I spent some time building an FM synthesis algorithm in microcode. There was no multiplier in the machine, so I had to avoid multiplies in the inner loop, and got that all working, hooked up a kit organ keyboard to it, and you could sit down and play 5 or 6 simultaneous FM notes. Then after my degree, I went to work at ISI, Marina Del Rey, where Bob came through showing the microdasis and working on a project there a little bit. We met there. And Alan Kay had left Xerox and came through ISI. And then he was hired to start up the research group at Atari. It turned out Atari never understood what a research group was, so we had kind of a turbulent history for 2.5 years there, whatever it was, 2 years. But Alan had hired in a bunch of young folks, fairly wide range of talents and dispositions, and it was a really interesting group. At one point, Atari realized that there were way behind in getting started with a 16-bit computer, and there was a fair amount of panic going around, and somebody said, well, Steve, why don't you work up a graphics chip for that, or consider that? So I went and sat down with the guru of Atari's 8-bit graphics chip and found out what it was like and how it worked, and nearly cried because it was so arcane and limited, and it was one of those things that was, appropriately so. You could just barely do what they did with the number of transistors they did. So it had all its justifications, but I was recently out of academia, and I thought it was just so horribly irregular. So I thought about what the basic capabilities should be, and sat down to do a chip architecture that would support software in a clean way. The idea was to write down what an instruction set for a graphics machine that could do multiple planes that moved with respect to each other, that had outlines, that could overlap and switch between front and back. Mm-hmm. And my whole first part of the design, solo, and then when Bob joined up, was about trying to make an instruction set for 2.5D planar graphics. And he did that. The idea was there were a certain number of objects that could be the size of the screen or smaller or larger. Each one has its independent location, and they were in a priority order. And the hardware then had to chain down through each, as many of the stack as necessary, figuring out which is the highest priority object that wanted to offer a color value for the pixel we're working on. Mm-hmm. After the end of Atari, I found that a couple of other groups, one at Intel and one, I think, General Instruments, had made chips with the same fundamental idea in the architecture. So I kind of felt validated later.
So I want to talk this kind of timeline-wise. What year are we talking? I think we're kind of wedged after the Atari 800 had come out, and now you're thinking about maybe what the next generation was going to be. Is that right?
Yeah, there was a 800 XL or something, but they were all based on the original basic layout with additions, and 16-bit chips were coming around. So this was, I think I started on this kind of late 1982, and so we worked on the Rainbow chipset through 1983 into 84, when Atari collapsed and was sold and changed utterly. Right. Is that right? We got the years right there. So I had this kind of design that was all back in my head, just kind of rationalizing capabilities. Bob helped me work out the details. We did a lot of standing at a whiteboard, making slash marks and arguing. For a lot of that time, the whiteboard in my office was the design, and we took a Polaroid picture at the end of every significant argument, the end of every day, keep a design history. I don't know where those Polaroids are now.
Oh, if you have them, I want to scan them. That sounds amazing.
I haven't found them. I have some later documentation that was more formal, but I don't know where those prints are. So we worked out what the hard parts were going to be, which was the number of memory cycles it could potentially take to chain through all the 16 or so objects to find that the lowest priority one was really the one giving you the pixel, but you had to fetch everybody else to see. It was, in a way, not quite deterministic that it would always succeed in producing a complex picture. You could overload it. But we figured that was okay. We worked out a table of what the limits were at some point, how much complexity you could have for what fraction of the screen, and left it up to software to game designers to allocate their budget of hairiness.
It was more forgiving as far as that than the Antic was. That is, it was smart about which objects were overlapping or not, and so on, and whether they had transparency or not.
Nice. So was even a prototype of this thing ever made, or was this all on paper the whole time?
We made a number of simulations, and we worked with a fellow named George Wang, who is part of Atari Semiconductor, who was taking basically, we got it down to the logic level and logic description. He put it into a schematic format. And I believe he did simulations of various sections because we went back and forth about that. Isn't that right, Steve?
Yeah, there was a fair amount of simulation. He produced timing diagrams of the various clocks and signals. But before that and during that time, we had some other people working with us on the chip. I think Jack Palovich made the first emulator of what rainbow graphics could be. You wrote some code that would run the simple instructions and set up a demo where there were a bunch of just frames, I think, that overlapped each other in different colors. And I remember looking at that and thinking, wow, this thing in my head that I hadn't visualized that way at all can do that. That's great. That's what I wanted. But I had never made the output screen picture in my head. So it was really fun. Sort of, reinforce the power of abstractions, I guess. Who else worked with us? Doug Crockford was working on documenting things. Go ahead.
Oh, yeah, Joe Gluck. We had this complex timing where we were fetching 2 pixels at one time. And we had to figure out the priority. And it was actually quite a complex state machine. I asked him to do it. Now, Joel is a game designer. And so he gave me back with this comprehensive basic program. It didn't take him very long. But he insisted that it should look like a game. So there are these pixels that are dropping down like one of these breakout things. And it was actually doing the simulation properly. It was kind of a shame that it was just for such a limited audience because it was so cool.
Yeah.
Sounds cool, but no one would see it. But a couple of people. Wow. Okay, I don't want to get in the way. You're doing a great job telling the story. Do you just want to keep going?
Talk about how chips got split and limited, and we got toward the final chip design, Bob?
Yeah. So we had basically a video timing chip called Gold, and we called it that because it was at the end of the rainbow. And then we, of course, had silver chips, which I think did the memory fetch, and basically figured out all the plain logic and instructions that Steve was talking about. The Gold chip was pretty straightforward. It was mostly generating video timing, and I don't remember. I think that we were able to use fairly straightforward linear feedback shift registers for doing the timing. Cameras were pretty expensive. One of the problems was we were limited to a 40-pin DIP package, and the chips themselves, I think, were pretty small. They weren't that expensive, but the packaging was a real issue. And we really needed advances in both the chip densities and the packages to really take the next step. The There was a interesting meeting. I wanted to drop into this that Steve ran, where we got all the graphics people. Do you want to talk about that one, Steve? Because I think that was a interesting meeting.
Well, yeah, the whole gold and silver chip thing, we had the logic worked out as one unified design, and then we ran into this 40-pin plastic packages or bus limitation and had to partition it. And that got kind of weird because the priority chains that we had sort of worked out, how they would neatly work on a chip, had to pass across pins between two silver chips. And I think that was the hardest part of the design, was getting those priority chains right to pass across the pins and still work. That's what I remember as being the hardest piece of the technical circuit design.
Mm-hmm.
Yeah, well, Atari was all kinds of management dysfunctional throughout the whole period. Alan isolated us from that pretty well, but one time there was some kind of management meeting, and Alan was away, and he asked me to sit in for him. I think he pretty well understood that I'm anything but diplomatic, so he wasn't really trying to soothe anybody or convince anybody. But we got in this meeting, and there was a vice president of software and a vice president of hardware and a vice president of computer games or something. There was a third one. There were three guys, and they basically went around the table and said, this project, this computer project, has software in it, therefore it belongs in my division. No, this project has hardware in it, therefore it belongs in my division. No, this project is going to run games, therefore it's in my division. And all I could think of to tell them was, guys, there's plenty of turf. We'll build the turf. You guys fight over it later. Don't get in our way.
Right. How'd that go?
I don't think you'd say it was well received, but they, either they didn't try to beat up on me later, or Alan did his insulating thing again. I'm not quite sure. I didn't personally get any bad fallout from that, and I don't think the research division did either.
So I get the impression from the interviews I've done that the research division was pretty well isolated from the rest of Atari. And it sounds like even within the research division, you guys were pretty well isolated, heads down, just working on this chip. Is that right?
Well, it started out with some isolation, and we even talked about upstairs and downstairs, because the 16-bit computer group that Bob had joined was in the first floor of the building, and the research group was in the second floor of the building, and there was a certain amount of social friction and resentment, I think, going on there. And when Bob started working with me, I think that sort of broke the wall, and I think it got better after that. But yeah, a research lab with young people who think they're hotshots can get a little bristly, I guess.
Sure.
There were some personalities. One guy had his business cards made up as director of off-planet operations.
Nice. I like that.
Somebody called him a space cadet, and he carried it through.
Was that Jim Dunyan?
Eric Hulteen.
Oh, that was Eric. Okay.
As I remember it.
Jim had the joke research.
Yes. Yeah.
Tell me about that. I need a story about Jim, because I can't interview him. So,
unfortunately, no.
Yeah.
But he had a very interesting paper, like a thesis on what was humorous, which actually was really well done.
Nice. It's that whole thing of, like, if you have to explain the joke, it's not funny. So he wrote a whole thesis explaining the joke.
explaining jokes in
Yeah.
general.
Right.
Oh, yeah. There's a whole history of humor. The paper itself wasn't that funny. It was just kind of cool that somebody's going to write about it.
Nice. Any other Jim stories? As long as we're there.
I don't have any others. Do you have any others, Steve? You remember Jim?
I'm trying to remember whether he's the guy who explained the 8-bit graphics chip to me and made me cry. Might have been. It was, yeah.
Why would the 8-bit graphics chip make you cry? Like weep with happiness, or?
No, with frustration at how each and every bit of it was particular and limited and specific, and how little generality there was in anything. And so a big chunk of motivation for me to do the 16-bit chip was to do away with that.
Mm-hmm.
With all these little bits that, in this one loop, you set this bit in the middle and something goes right, and if you don't know about that, you can't get the job done. And I really wanted something that described pictures in terms of, you put a picture down in memory, and what the hardware will let you do is slide it around, bound it so that it can be, a small object, and you're not fetching the blank parts of it all the time, and have other planes stacked up on it, so that if the priority mechanism worked by looking at bounds. So the first object, the highest priority object, the hardware would examine its bounds, and those bounds registers were in the silver chips. It didn't have to do a memory transaction to keep track of that. And the location, the XY offset of each plane was also in the little instruction block. So it could first check whether the pixel you're working on right now is within the bounds of the object, and then within the bounds of the object where it's located right now. And if it is, then go fetch the color that object has at that location in its chunk of memory. And check whether it's the transparent color, so that objects didn't have to be just rectangles. You could put, a round Pac-Man face or whatever, mm-hmm. By using the transparency value. And the instruction definition was keep going at this pixel location through all of the objects until you find one that tells you what color to be, that isn't transparent, that is within its bounds. There was one global background color. If you fell through every object, you would hit the background color register, and that's what you would put up on the screen.
Wow.
Yeah, what do you know? Chip architecture in one sentence.
It just sounds insanely complicated.
It was a lot of design.
Yeah. Well, what I wanted to the instruction set to capture and simulate was a stack of transparency sheets that you would draw things on the different sheets, and then you could move them around and look through the whole stack and see whatever was in front.
Sure, that makes sense.
So each object was described by its size, which could be whole screen, like an old-fashioned Atari playfield, they called it, or bigger than that, to make a playfield that you could scroll around on, like walking around through a world or whatever, or smaller than that, to be a player or a sprite or some other graphical object. And all of the priority arrangements were by pointer chaining in order, so that in order to move an object or in order to swap its priority with another object, you did not have to shuffle color bits in memory at all. You swizzled pointers in the instruction block. And that's what took care of, an object popping in or out of existence. Or you could push it off to somewhere on the side where it wouldn't show, and then no memory traffic would be wasted on it.
Mm-hmm.
It's basically a linked list of a structure which had, the XY origin points, width, height, had the stride, which is a distance from the line distance between the line, and which color field, and I think that there were some other fields for doing run length encoding and some other features, and what transparency meant.
Yeah, the older Atari machinery had different color modes. You could have 1, 2, 4, or maybe 8 bits of color per pixel, and I carried that through into the newer one. So each object could have different could have its own color depth. All the colors went through a lookup table. Do you remember, Bob? Was that lookup table per object? I think it was.
I actually don't remember, but I do remember we had a line buffer, and I thought the lookup table was afterwards. But I think we had,
okay.
We had different lookup tables
that
for.
would put them in common. Yeah. So the line buffer was mainly to allow the complexity of constructing the pixels on a line to be non-uniform across the line, and as long as you had time to get it all done by the end of the line, it was okay, rather than having to have a sharp limit at the left edge and lenient at the right. If you had to deliver each pixel within a pixel time, you only had to deliver all the pixels within an average of a pixel time each. There was a run length mode.
Had this chip come to fruition, was going to be part of the Sierra project? Is that right?
Oh,
Sierra or Eva?
Sierra was a interesting conversation between Doug Crockford and myself. I was hired in originally to actually design this computer. I kept doing block diagrams. One time, I borrowed Jack Palovich's Macintosh because he had a brand new Mac, and it was cool, and I wanted to play with it. And so I borrowed it to use Mac Paint. I drew a block diagram, and that ended up in a dumpster which got archaeologically discovered and posted on the internet. And there were all sorts of rumors that we had deals with Apple and all this. No, I had borrowed that.
Nice. So you were working on the Sierra project as well, Bob?
Oh, we'd come up with these ideas, but until we had chips, there was sort of no point in doing, a computer. Again, it was the whole bit about processor wars, which processor to use, and it was like there was a favorite one. The design would change weekly, and it just seemed pointless because until you had Amy and Rainbow and Realization, it wasn't worthwhile doing. Because that whole industry can change in 18 months.
Sure.
Also, there are going to be new things out by the time we had those chips out. It just didn't make any sense to actually do anything. But we're always working on it. I'm always designing, so I kept up with that. And Doug Crockford is a delightful person. He taught me how to juggle, which was an interesting thing to learn. And we worked on a variety of things. We espoused philosophy about computers and where they're going to go and all that, all this stuff. And he had, what if we had this processor? Okay, I'll draw it up and let's see what we can, how it looks. Let's see how the data flows and if we've got the bandwidth that we need. And so I draw up a block diagram for him. And, even with the early EVA project, it was like, what's this thing going to look like? And so we were describing, we had actually a mechanical group, and I described it to him. We want something sort of a desktop, and, small and stuff. And, I've got it. He goes, this is a Greek fellow that, I've got it. And he comes back with this rosewood CNC machine, which I have no idea what happened to it, but I always liked that idea. I did something like that at Apple for a thing called Texas Ranger, which was a right-on display with a handle for kids. It was basically an iPad that was an inch thick. Anyway, fun stuff. You always do prototypes like that to get an idea. Then you can figure out, okay, how are the boards going to fit in this? Are you going to be able to cool it and that sort of thing? And most of the processors probably would have worked fine. I was a little nervous about the 286 because it got really hot. Mm-hmm. It took quite a few years for Intel to come to grips with trying tons of power for their processors. And most of these were pretty straightforward, not a problem. Mm-hmm. So, anyway.
Cool. Hold on. I think we lost Steve. Let me try to get him back here.
Okay. Where is that? They had an Alto upstairs. You know about the Alto?
Xerox Alto, yes.
Yeah. It was a cool machine. I would sneak in late at night and play with it. So the Alto, this is a machine that Steve had worked on at Xerox PARC, came from Xerox PARC. It was a microcoded system. It would run Smalltalk, Mesa, Lisp, and a bunch of other things. It was one of the first computers that had Ethernet. It was also one of the first ones that hooked up to a laser printer. It had one of the very first graphical user interfaces, and it had object-oriented languages. There was an incredible amount of innovation. So I'd go up there late at night, and the lights would be totally out, and I'd just be on this thing with this widescreen, and I had not a clue what I was doing. Alan Kay comes through with this big group. I just see out of the corner of my eye this guy in a suit, but he has a Kermit the Frog tack. Mm-hmm. And I just sort of look and I say, oh, nice tack. And he says, yeah, this is a close personal friend of mine. I look up and it was Jim Henson. So this is where Jack was talking about getting rock stars through and stuff like that. That. And that was the only time I saw one of these tours come through. So I had to give a demo about something I had not a clue about I was doing.
You're just messing around with this machine, and all of a sudden you're the resident expert for Jim.
Yeah. Alan was like, it was amazing. He's talking, he's showing these stuff, and it was like, he didn't care. He could actually talk over what I was doing, and it was, and it just sort of fill it all in, and I didn't have a clue what I was doing.
So then what? I mean, at what point did you realize that it wasn't going to be a thing, and how did everything come to an end for the chip and for you at Atari?
It was basically pretty sudden. We were told things were going to be shutting down, and there was by the time there was quite a bit of camaraderie among the researchers, and so they had a list of companies of where to go. We were basically doing our own outsourcing to find new jobs. It was kind of interesting. We were given permission at this time to try to take Rainbow out, try to find some other place to land it. You have to understand is that we actually got the thing up to the point of tape out. It had been simulated, in and checked all the logic was correct. They had it all the way down to tape out. Amy, they got all the way through to actually having a chip produced, but we were a little bit behind them, and we had it in tape out, and we were taking it around, and we'd even met with Shiraz and his merry band of pirates who came from Commodore, and that was the basically the Tramiel takeover, and they were just curious on what we had because we were trying to get hired out as a team. We went to AMD, we went to a variety of companies, but nobody was terribly interested, and they were looking more of it. Well, you want to hire in here? We have other stuff, and so that was kind of the end of it. What happened was that Steve and I both got hired over into HP Labs. They hired 30 of us. In fact, the guy who laid us off, John Decima, was at the front door of HP Labs. He opened the door for me after a few weeks of that we got laid off, and I went and started HP Labs, and he's holding the door open for me, which is sort of ironic. And that was kind of the end of it. We just didn't have enough time as Atari, where it just simply imploded and the project stopped.
Yeah. So I want to talk a little bit about the Amy chip. It sounds like you had a bit of a hand in that as well. Is that right?
Nope, not at all. I knew the guys who were in it, but no work whatsoever with them.
Okay. All right.
I knew how it worked. It was a sine lookup table. They would have a quarter of sine wave and then do the appropriate bit twiddling to get the full sine wave, and it was an additive system.
Mm-hmm. Was it terribly disappointing when you didn't get to see this project come to fruition, or were you? How'd you feel about it?
Well, yes, it was pretty terribly disappointing. When the end came, it seemed very sudden to us, and we had a cozy little working group of I think it was 5 people by that time, and I remember feeling that it was the hardest thing I'd had to do in my life to tell these people they were laid off. I had never wanted to be a manager, and actually wrote up a little thing for Ted Hoff, the research manager, later on, saying, well, in order to get this project done, it needs a manager, and it looks like I'm the one, but this is only temporary, and I get to be a researcher afterward again. Okay, and got an okay on that. So when the end came, I started looking for how we could keep the team together and go somewhere else and do the same thing or something similar. And first, of course, interviewed with the buyers of Atari, show off the chip, show off what it could do and how it was almost ready. And apparently they had their own graphics design that they came in with and weren't much interested in ours. So I don't know how many different companies I looked at, interviewed with, tried to, interviewing for a job for myself, but pitching it as, here's this little group and we're well underway. We know a lot about how to do this kind of thing. Let us come on together. And HP Labs bought into that to some extent. I think Bob and I went there, and was Jack along too, Bob?
He came later.
At HP? Came later, yeah, okay. And Doug and Fraser did not come at that time, I believe. So there are three of us landed at HP Labs with fire in our eyes to build graphics processors, and turned out the spot we landed in HP Labs looking at graphics had in mind something more like a rack than a chip. And we ended up doing things a little bit differently. From, must fit in 40-pin plastic to here, you're putting together this backplane on a rack, and for the power, we're going to use 1/4-inch square bus bars.
The power was object.
What was that?
Power was no object.
It's a different scale than you were working before, it sounds like.
Just vastly different scale of things, yeah.
Right.
Yeah. So we ended up doing some graphic stuff there, but it had different flavor all throughout.
Sure. It sounds like you tried to shop the chip itself around to different companies. The Rainbow?
No, I didn't own the chip.
Sure.
I was clear about that, but what
Right.
I was trying to shop around was, a team, that had
right.
just built a chip and was highly focused on getting that sort of thing right. And hey, we can do something that isn't that chip, but by golly, we know a lot about how to do chips like that.
Right.
No.
Maybe I tried. I don't remember getting any traction with a formal release or anything, though.
I don't think so. That it never happened, but I think we got permission from Ted Hoff to, that we could take it out.
Oh, okay. Okay. Yeah, so that was a weird job hunt where I was job hunting for a team rather than just me.
Right. Hire me and all my friends. Yeah.
Yeah.
What haven't I asked you both about that time that I should have?
I think this one's probably been written up elsewhere, but the research lab, or a chunk of the research lab, had a completely fictional manager
What?
named Arthur T. Fischel.
How did this come to pass?
Well,
Eric Olson.
yeah, there was some sense among some of the feistier young researchers that some of the managers, not Ted and Chris and Alan, but some of the managers under them were not really paying attention. There was a mandated weekly report that was supposed to be 3 paragraphs on one sheet from I forget what all groups, and so Arthur Fischel started writing this report for one of their groups and would just put complete argle-bargle in the middle paragraph. And this went on for many months before the manager receiving the report noticed. So when the end came, I was fairly clear that I had to tell my team they were laid off, but some of the other groups were a little less structured about that, and one of them left it up to Arthur to do the layoffs notices. Like I say, I think this has been written up in a different piece of Atari history published already, so I'm not going to try to contradict any of that, but
Oh, that's still good.
I remember that there was sort of sharp-edged, pointed whimsy going on.
Lovely. What do you both do today?
Well, I work as a consultant, and currently I've got contracts with Oracle, and I'm working on their high-end, one of their high-end servers.
Nice. And you, Steve?
Thank you.
Yeah. I passed through Apple and a number of other places, and landed back at Apple just a few years ago. They gave me back my original badge number after 21 years off. I thought that was pretty cool.
Nice.
So I'm working in video compression quality measurement. Fairly arcane thing to do. I had passed through a video codec.
Wait.
Little startup company.
We've been talking for 58 minutes about graphics chips and things, and now you say it's fairly arcane. I barely understood a thing we've discussed in the last hour.
Okay, I meant that to be a slightly slow motion emphasis that as arcane as the graphics chip architecture and layout may have seemed when we did it in 1983, the project of making a computer program that watches a video and says what its quality is as judged by humans is somewhat more arcane.
It sounds fascinating.
That is, it's not a solved problem, so I'm still working on it.
Nice. All right, last question for each of you. Bob, if you could send a message to the Atari computer users that still exist, and you can right now, what would you tell them?
Thanks for all the fish. I don't know. It's a fun experience. Wish that we had gotten, further along, that it actually became a real product. There was a lot of really good work that happened, and like so many of the stuff that happens in industry, it goes away sometimes with a whisper, and that's the case in this one.
Yeah. Steve, same question. Send a message to the Atari computer users that are still out there.
Have fun.
Succinct.
I don't
like
have
it.
any details, anything else to say. The piece of Atari design that I mostly worked on is not in their hands, so not much I can tell them.
Yeah.
After the end of Atari, I used Atari Computer to be online. I remember being a member of an early bulletin board system that was hosted in Finland, and every time I would turn on the modem, it was like, wow, around the world, okay.
Nice.
That's not remarkable anymore, but it sure felt that then.
Yeah, absolutely. I think I have what I need. Thank you both very much.
Thank you,
Great.
sir.
Thank you.
If you enjoyed these interviews and would like to contribute something, I encourage you instead to donate to one of our favorite organizations, the Internet Archive, at archive.org. The Internet Archive is a nonprofit digital library with the stated mission of universal access to all knowledge. They've done incredible things to preserve computer history, including hosting thousands of programs in an in-browser Atari emulator, creating the Wayback Machine, and offering full-page scans of countless Atari computer books and magazines. Make your tax-deductible contribution at archive.org/donate.